a picture 1 meter tall is up here. Here it is. In fact, I'll put some color on it so you can tell it's the picture. Okay, picture's up there, it's on the wall. And you've got the eye of someone looking at it down here at E. E for eye. That's confusing, isn't it? Anyway. And you have this angle subtended at the eye by the picture. Okay, so that's angle BET, they're calling it theta. Okay? So you can see, if I moved the observer, if I moved them closer to the wall or further away from the wall, that angle theta is going to change. It's going to get bigger, smaller. I'm not really sure which way it's going to go, but it's going to change, is the important thing. And then you've got a few other things that are piece of information on there. Show that theta equals, and then they give you a function. Okay? So, what kind of result have we got here? I've got theta in terms of two right-angled triangles that are sitting on top of one another. Okay? So, let's have a look at what this angle here in the corner, BEP, is first. Okay? Now, the formula, sorry, not the formula, the equation they've given us is all in terms of tan inverses. Okay? So, we're going to start off with tans and move to tan inverses later, which makes sense because you've got an opposite and an adjacent side in these right-angled triangles. Okay? So here's the first thing that I would write. Tan PEB is equal to 3 on x. Okay? I suppose if you want to be really pedantic, you could say in triangle, because we're just noting the right-angled triangle ratios, right? Okay, there's one. So if I say, well, what's PEB equal to, not the tan of PEB, then that's where my tan inverse comes in, right? Tan inverse of 3 on x. Okay. Now, what about this other angle in here? This whole angle in the biggest right-angled triangle, okay? That's PET. I can use exactly the same trick, and because it's 3 plus 1, that's why it'll be 4. That's the opposite side, right? So in triangle TEP, the same angle in the corner is equal to 4 on x. Yeah? So now if I just want the angle on its own, I take tan inverse. Okay, no problems. So you can see I'm almost there, right? The angle I want is the difference between the two angles that I just found. Okay? So I can say theta is equal to the big angle minus the little angle. This one first. Okay, so there's part A, yeah? Any questions so far? That part's okay? That part's just set up, yeah? Now, by the way, it's worth noting, you know, this kind of part of the question, they're sort of guiding you through the process, but sometimes they'll just give you the situation, and they'll land you straight on part B, which says, show that theta is maximized for a certain value of x, okay? So we have to sometimes work all of this out on our own, but that'll come with practice, okay? So if I'm looking for a maximum, I'm looking for the biggest angle, theta, that I can get, right? So it's kind of like, we're used to having y over here, y equals something with respect to x, but it's theta. That's fine. We can still differentiate with respect to x. It's just that we've got all these tan inverse functions, right? Okay, so chain rule, right, which is what we practiced last lesson. Let's do the inside first. What's the derivative of 4 over x? It's 4x to the minus 1. What's the derivative? Yeah, good. Minus 4 on x squared. That's x to the minus 2 down the bottom. Okay? All right, there's the inside. What's the outside? What is tan inverse? It's 1 over... Yeah, so usually we would have x squared here, but x is not the inside function. It's 4 over x, isn't it? So it should be 16 on x squared there. Okay? Good, and we'll just rehearse that for this function over here. Minus, this is going to do the same thing. And this is also going to do the same thing. But I've got 3 squared on x squared instead of 4 squared. Okay. It's almost done. Let's tidy that up just a little bit. This is positive here because of the double negative. That's negative, so I'm going to switch them around so it's not minus in front, which is a bit weird. Okay. So I'm going to get 3 over, now what happens to this denominator? Those fractions are going to cancel. I'm going to get x squared plus 9. Is that okay? That's from this term over here. And then here, that minus sign, I'll put it there. 4 on the top, and in much the same way, the denominator gets a little bit simpler. So there's my derivative. Okay, now, why did I differentiate again? What was the point? Where am I going to take that result? Good, yeah. So I'm looking for a maximum, right? So I'm going to say, for potential turning points, this derivative ought to be 0. Okay? So in other words, this thing is equal to 0. Which at first looks terrible, but actually, when you get this on the other side, and as I will in a second, cross multiply, actually it works out really, really simple, right? What are we going to get over here? 3x, excuse me, squared plus 48. 4x squared plus 36. So if I bring everything around, x squared is equal to 12. Yes? Okay. Now what?
Wait, it has to be positive.
That's right. So out of this line, I'm going to get 2 solutions. So I'll write those 2, and then I'll disregard the negative one. Okay. So I'm going to get plus or minus. There's a 4 in there, right? So that'll become 2 root 3. Okay. But because of what x is, namely a distance, right? That's why I can say x has got to be greater than 0. Okay. Therefore, it's the positive one only. Okay. So now that was actually where we were. That's the number we expected to arrive at. Am I finished? Yeah, I don't know, because I said this is potential turning points, right? So I've found a stationary point, but I don't know if it is actually a turning point, and I don't know what kind of turning point it is, if it is. So how should we go about it? What do you think is the best approach? Remembering that this is our derivative, right? What do you think?
The good old second derivative.
So I'm going to draw up a table. What is 2 root 3, by the way? Root 3 is like 1.7 something. So this is kind of like 3.4-ish, right? So you can pick 3 on one side and 4 on the other, okay? And you can draw yourself up a table. Okay, so I'll wait for you guys to get some values. I think I've already worked it out, but I want to make sure you guys complete the question.
What is the shape of here? Whoops.
What do you do if that turns out to be minimum?
If it turns out to be a minimum, and so the first thing is be suspicious of your own answer. I would probably expect, especially when they say show that, right? I would expect that maybe I've done something wrong with my derivative, okay? Because usually having got it right, you know, it's not that hard to put the values in. Where I'm more likely to have gone wrong rather than evaluating it is that I've got this derivative wrong, okay? It's suspicious that I would have gotten it wrong because I've got the right stationary point, right? So it had to be valid to some extent. But maybe check your calculator even, that you're inputting it correctly, okay? So you should get, we're looking for a max, right? So we should get positive, 0, negative. That's what I'm hoping, okay? Has anyone got a value for any of these?
1 on 150.
For this one? Okay, so that is increasing, just like we wanted, okay? Has someone got a value for 4? Good, okay. So this is what we're expecting. Up, flat, across. So therefore it's a maximum, which is what we need to show, right? Okay, excellent. Now let's read the last part of the question, because some of the hard parts of this is just interpreting the way it's worded, okay? Show that the maximum angle subtended by the picture at E is, and then they give you a value, okay? Now what are they actually talking about? It would have been nicer if they just said, use the language they've already introduced, right? What is that angle that's being subtended at the observer by the picture? And the angle is theta, right? There's the picture, and there's the angle it's subtending, okay? So really what they want us to work out is just theta at that point, okay? So this doesn't sound so hard. Let's take our x value, which is the maximum, and let's plug it into our expression for theta, which we worked out in part A, right? Let's give it a go. Okay, now I think it was tan inverse 4 on x and then 3 on x, right? So I've got 4 on 2 root 3 minus. Okay, now what do I do? Okay, I will take the tan of both sides. Now, you know that you're going to have to take the tan of both sides eventually. Here's why. These two numbers, whatever they are different to each other, right? So they're not going to talk nicely while they're still nestled inside their tan inverse functions, okay? So to get rid of them, I'm going to have to take tan, use my expansion formula for tan, and then they can interact with each other, and I'll have to take tan inverse again. Before I do that though, there's something I can probably do to make it a little easier for myself, right? Yeah, these look terrible, right? Let's make them a little better. What have we got here? That's going to be cancel. That's just 2 on root 3. And what's this going to be? Root 3 on 2, right? It's the reciprocal, yeah? Okay, so now I'm in a position where it's nice and simple. I can take tan on both sides, okay? So tan theta over here, okay? Now I could write it out, but I think you've got it in your head well enough that if you're taking tan of, now this is a difference, right? A minus B. What's it equal to? What's the expansion? What's the formula? It's the fraction, right? What's on the top?
First one plus the second one.
Yep, tan A minus tan B, right? It's the difference, yeah? And the plus is on the bottom. Okay, so I'm going to have tan of tan inverse, okay? Which is just equal to whatever that is, right? So let's have a look at the top. That's tan of tan inverse of 2 root 3. Which is just 2 on root 3. 2 on root 3, sorry. This is the second one. And then what do we have on the bottom? 1 plus the product. Now, because it was chosen very conveniently, right? The product of these two will be just 1, right? Because they're reciprocals. So I'm going to get 1 plus 1 over here. So that's 2 on root 3 minus root 3 on 2, all divided by 2. So far, so good. Let's do the division. So I'm going to get 1 on root 3 on 4. So now I've gotten rid of my fraction. Put them together. What's a good common denominator to use? You could use 4 root 3, right? That'll work. That'll put into two fractions, right? But you've been given a destination, right? You don't want to get it to anything. They've told you we should get to root 3 on 12, right? And 12 kind of makes sense because that's going to let us, it's going to let the numerator kind of simplify together. Have I done something wrong?
No,
It's okay? Yeah, okay. So if I make it 12, let's see. I'll do a couple of extra steps here. That's root 3 on 3. Root 3 on 4. So this is going to be 4 root 3 minus 3 root 3 on 12. There it is. Can you see it came out? Yeah. So let's make a new column. Ta-da! I've got tan theta on the left-hand side, root 3 on 12 on the right-hand side, and I'm there. I'm home. Finished. Okay. Just out of curiosity, what is that? Like, can someone get a calculator out and do tan inverse of what is the angle? I'm just kind of curious.
0.14 radians.
0.14 radians.
Or do you want degrees?
Yeah, let's do degrees as well. still picture 8 degrees, 13 minutes. Does that sound about right? It looks like it's in the ballpark. Now, whenever you do max min questions, I hope you get into the habit of always checking your results at the end, particularly when they're weirder ones like that, and it's not intuitive what that's equal to, just to make sure you've got a reasonable result. I know here they expected, find this value and they told you, but you don't always get that luxury. Okay. Any questions on any part of that?